Introduction to moles. Using mass to determine the number of particles. I put a full stop, a period, at the end of that statement. I rarely do. If you look at that period and imagine it was ink on the paper in front of you, there are so many particles in that tiny area. Imagine a stadium when it's full of people. Could be a rock concert, the biggest one ever. Could be the Super Bowl, the World Cup final in soccer, the Olympic Games. There's enough particles in that period for every single person, every head you see in that crowd to have 10 million each. In fact, it's considerably more than that. Atoms are incredibly small. When we quantify matter, we're considering a very large number of atoms, and this is where the concept of a mole of atoms comes from. The mole makes it possible to correlate the number of particles with a mass that can be measured. We can easily measure the mass of anything. We can use the mole concept to relate this to the number of particles present in that mass. The mole is the SI unit of the amount of substance. 1 mole contains exactly the number of elementary entities given by the Avogadro constant. Entity is an interesting word. It means anything you like. Atom, ion, molecule, electron, anything. The Avogadro constant gives us the number of particles in 1 mole. A mole is a number, that's it. Nothing more complex. It's like a dozen. A dozen of anything contains 12 pieces of that thing. A mole always contains 6.02 times 10 to the 23 particles. The particles could be atoms, ions, electrons, molecules, anything you want. The really significant thing is that that number, 6.02 times 10 to the 23 protons or neutrons, weighs 1 gram. Converting the number of moles to the actual number of particles. Here we're really using relative atomic mass, and here's a definition. It's the average mass of all the naturally occurring isotopes of an element relative to 1/12 the mass of a carbon-12 atom. 1/12 the mass of a carbon-12 atom is 1, but it's our definition. So, relative atomic mass is the average mass per atom of an element. We're talking about atomic mass, we must be talking about an element. Dividing by 1/12 the mass of one atom of carbon-12, which is 1. Relative molecular mass, if I'm saying molecules, I must be talking covalent. Defined in a similar fashion. The average mass of a covalent molecule divided by 1. Relative formula mass. Can't use molecular if I'm talking about an ionic substance. But the average mass of the formula of an ionic substance divided by 1. The Avogadro constant is a quantity, and is given the symbol L. Units per mole. Moles to the -1. So, L is 6.02 times 10 to the 23 particles per mole. Simple calculation, it says sample, but it is simple. Use the data below to calculate the mass of 1 mole of lithium atoms. I'm given the mass of 1 lithium atoms. A mole of lithium atoms is found by multiplying the mass of 1 atom by the Avogadro constant. 6.94, which corresponds to the relative atomic mass of lithium in the periodic table. So 1 mole of protons weighs 1 gram. 1 mole of neutrons weighs 1 gram. 1 mole of carbon-12 weighs 12 grams. 1 mole of oxygen-16 weighs 16 grams. a mole of oxygen molecules, now we're talking O2. I need to multiply my 16 by 2, 32 grams. What this comes down to, what it means, is that we just add up all the atomic masses of the atoms in a compound to get the relative molecular mass of a covalent compound or the relative formula mass of an ionic compound. CaCO3. Given that carbon is 40, carbon 12, oxygen 16. And there are 3 oxygens, so 3 16s, 48. Add up everything, comes to 100. That's my formula mass. It's ionic, so I'm talking formula mass. 1 mole is 100 grams. That means the Avogadro constant, 6.02 times 10 to the 23 particles, is 100 grams. By the way, how did I know? CaCO3, ionic, because it contains a metal. As does MgOH twice. Mg is 24, oxygen 16, hydrogen 1. But I've got 2 oxygens and 2 hydrogens. Adding everything up gives me 58. Formula mass of 58. 1 mole of MgOH twice weighs 58 grams. And that number of grams contains 6.02 times 10 to the 23 particles. I've said particles of Mg2+, yeah, because MgOH2 contains 1 Mg2+ ion. If I wanted to get the number of particles of OH-, well, there's 2 of them. I'd need to multiply by 2. CH3COOH. Carbon 12, hydrogen 1, oxygen 16. Adding up my masses, 2 carbons, that's 24. CH3, that's 3 hydrogens plus 1, that's 4. 4. 2 oxygens, 2 16s gives me 32. Comes to 60. CH3COOH has a molecular mass of 60. Half a mole would weigh 30 grams. Relative atomic mass and relative formula mass have no units. It's because they are relative. And the values of the relative atomic masses given to 2dp in the data booklet should be used in calculations. I've rarely done that in this video. I'm really looking at outlining the concepts rather than focus on accuracy here. Back to that one. Solving problems, converting number of particles, amount in moles, and mass in grams. Number of moles is mass divided by molar mass. N for number of moles, small case n, small case m for my mass, capital M for my molar mass. 1 mole of CaCO3 is found by adding all the masses. We've been doing that. Comes to 100 grams. That contains 6 times 10 to the 23 particles of calcium ions, Ca2+, and 6 times 10 to the 23 carbonate ions, CO3 2-. What's the mass of 0.2 moles of MgSO4? Well, I'm given the relative atomic masses. First, I'll work out the mass of 1 mole, 1 Mg, 1 S, 4 oxygens, comes to 120 grams per mole. For my 0.2 moles that I was requested for, multiply that by 0.2. Now, how many moles are there in the following? Moles is mass divided by mR. I've done the first one. I'm given the relative atomic masses of the relative elements here. 44 grams of CO2. I need mass. My mR is 44, 1 carbon and 2 oxygens. To get my moles, I simply divide the mass by the mR. The answer comes out here. 2 more examples. I have the answers here. If you'd like to try those, great. I'm highlighting the answers now so you can see. Next, what's the mass of the following? Rearranging my equation, moles is mass over mR, gives me mass equals moles times mR. And I'm told I've got 0.1 moles, and I'm told that I have a mass of 5.85 grams. I get my molar mass. Mass is equal to number of moles, 0.1, given, times the MR, which is 58.5, comes to 5.85 grams. Again, a couple more if you'd like to try them. The answers are here. Third type of question, final. What's the MR of the following substances? I've rearranged my original equation, moles is mass divide MR, to give me MR. MR is mass divided by moles. My number of moles is 0.1. My mass is 40. 40 divided 0.1 is 400 grams per mole. Noting the units. Again, two more examples. If you want to pause and check, answers are here. Using molar masses and chemical equations to determine the masses of products formed. The only reason we bother balancing equations is so that we can work out the amount of substance used up or produced. We usually measure the mass of a solid in grams and the volume of a gas in liters. So, I'm given an equation. I'm given the relative atomic masses. Question: what mass of MgSO4 can be produced from 2.4 grams of magnesium and excess sulfuric acid? Excess means you've got more than you need. In other words, when it comes to calculations, don't worry about it. There's enough there. The equation tells us that 1 mole of Mg produces 1 mole of MgSO4. And 1 mole of Mg is 24 grams. Therefore, it would produce 1 mole of MgSO4. How many moles do I have? I have a mass of 2.4 grams in the question, divided by 24, 0.1 moles. That means 0.1 moles of MgSO4 will be produced. The equation shows me 1 mole of Mg gives 1 mole of MgSO4. I can figure the mass of 1 mole of MgSO4 by adding up my relative atomic masses as given. Mg, 24, S, 32, oxygen, 16, but there are 4. 4 times 16 comes to 120 grams. We will produce only 0.1 mole, and moles is mass over formula mass. Mass, therefore, is number of moles times MR, 0.1 times 120, 12 grams. Finally, another equation, CaCO3 plus 2HCl gives me the products. Question: what mass of CaCl2 could be produced from 5 grams of CaCO3 and excess HCl? Instantly, I'm not worried about the HCl. I don't care that my coefficient is 2. There's enough. 1 mole of CaCO3 is 100 grams. 5 grams comes to 0.05 moles. 0.05 moles of CaCl2 will be produced. 1 mole of CaCO3 gives 1 mole of CaCl2. I can work the mass of CaCl2, 40 for the calcium as it turns out. 35.5 but times 2 for the chlorines adds up to 111 grams. we're only going to get 0.05 moles, multiply my 111 by 0.05 to get my final answer. And that's it. That's the introduction to moles. If you found that at all useful, please like and subscribe. That just helps me.